We are now going to begin to focus on the unit circle. At this point in time, because of what we've been doing in previous classes, both in person and remotely, you should already know how to do parts of the unit circle. If you need to, go back and watch the video from last week titled Introduction to the Unit Circle, and then in parentheses it says 10.3. Basically, this is what you should know by now. You should know the degrees, radians, and coordinates of the quadrantal angles. You should also know the degrees, radians, and coordinates of the entire first quadrant, which you can see right here. Okay? So again, if you need to, go back and watch that video from last week. Starting with these unit circle notes, the first question is, what is the unit circle? And the answer to that is, it is a circle with a radius of 1. You can see here in this graph, that's a unit circle. It has a center of 0, 0, and a radius of 1, which is what gives us the coordinates of our quadrantal angles. We're going to find the coordinates of the special angles in the unit circle. I'm also going to mention the degrees and the radians just for that extra practice. The first question here is, what are the coordinates of 0, 360, 90, 180, and 270 degrees? So the first thing that I'd like you to do is we're going to go ahead and we're going to label our quadrantal angles. This is 0 or 360, 90, 180, and 270. If I would like to know the coordinates, remember, there's a radius of 1 in the unit circle. So the coordinate here at 0, 360 is going to be 1, 0. Just push it over a little bit more. Okay. The coordinate for the 90-degree angle is going to be 0, 1. The coordinate here, once again, because there's a radius of 1, since I'm moving left, is going to be negative 1, 0, and the coordinate here will be 0, negative 1. I'd also like to remind you what the radians are. A full rotation starts at 0 and ends in 2 pi, which makes this pi over 2, and 3 pi over 2. So now you can see the degrees, the radians, and the coordinates. Next, we're going to draw a segment representing a 30-degree angle. That's the first thing it asks us to do. So 30 degrees is going to be in quadrant 1 between 0 and 90. We want to show a radius that actually looks like it has a theta of 30. So 30 is about a third of the way, well, is exactly 1/3 of the way to 90. So I'm going to draw a radius that's about a third of the way. So that would be my 30-degree angle right there. It says, now make a triangle with a 30-degree segment and its hypotenuse. So what we're going to do is we're going to take that point that's on the circle and drop it to the positive x-axis, just like what we did in class last week. And then it asks for the side lengths of 30 degrees. So this is where we used our special right triangles, and we solved for the values. Remember, in a 30, 60, 90, for the unit circle, the hypotenuse is 1. And the hypotenuse is double the shortest leg, so that would be 1/2. And to get the longest leg, we multiply the short by √3, so that gives me √3 over 2. I also do want to mention what the pi radians are. The 30 degrees is equivalent to pi over 6. If you ever forget that, or if you're just not sure which one it is, you learned in your task 2 that you could take 30 degrees and multiply it by pi radians over 180. And if you simplify that, you'll notice the degrees cancel. We're left in terms of radians, and then we have 30 over 180, which is 1/6, so that's pi over 6 radians. Just figured I'd throw that out there. So it says next we're going to be drawing a 45-degree angle. If I'm thinking that we're starting at 90 or 0 and going to 90, 45 is exactly halfway between those two measures. So try to draw a radius that is cutting quadrant 1 in half. And now we're going to make a triangle by taking the point on the circle and dropping it to the positive x-axis. This is a 45, 45, 90 that we've created, so the theta was 45. And because it's in the unit circle, we know the hypotenuse is 1. The hypotenuse, if we're thinking about the rules, is the leg times root 2. So you could go ahead and write the equation 1 equals x root 2 and solve, but we already did that in class, so you should remember that we would end up with root 2 over 2. And because it's a 45, 45, 90, I know that the legs are congruent, so both of them have side lengths of root 2 over 2. All right, last one, we're going to be drawing a 60-degree angle. So if this is 0 and this is 90, 60 is about 2/3 of the way there. So it's closer to the 90 than it is the 0. And then we're drawing a triangle, just like what we have been doing. So essentially, we've created a 30, 60, 90, where 60 is here because that's my theta, and then 30 is here. So we can clearly see that the shortest leg is across from the 30. That's going to be 1/2. And the longest leg is root 3 over 2. The hypotenuse is 1. It's the same measures as the 30-degree reference angle, is just the x and the y values are opposite of one another. All right, I'm going to go back. I know I didn't do it for the other one, but 45 degrees is equivalent to pi over 4, because if this is pi over 2, it's exactly halfway between 0 and pi over 2. And then the 60 degrees is pi over 3. You could think of it as 30 degrees, or excuse me, 60 degrees is 1/3 of 180. So 180 is equal to pi over 3. That's one way you can look at it. Or, of course, you could always take 60 degrees, multiply it by pi radian over 180, and find out what that would be. So you have a couple of options here if you ever get confused. Now we're going to put everything together using reference angles and the sides of the quadrants. The first thing that I'd like to remind you of is that this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. We, on the first page, talked about the lengths. So now I'm going to write the coordinates. A coordinate is always x comma y. So for 30 degrees, it's going to be root 3 over 2 comma 1/2. For the 45-degree reference angle, we mentioned that both of the legs are root 2 over 2. So x comma y would just be root 2 over 2, root 2 over 2. And then the 60-degree reference angle is basically just the opposite of the 30. We're going to have 1/2 comma root 3 over 2. Or you could look back at page 1. You can see here's the x value, it's 1/2. Here's the y value, root 3 over 2. Those are the coordinates for 30 degrees, 45 degrees, 60 degrees, or that is also pi over 6. If you want to write this as well, I'll do different colors just so you can see. That's pi over 6, pi over 4, and pi over 3. Now, it just so happened that in quadrant 1, these were both positive values, and by these I mean the x and the y values, because we went right and up. So you can see each of my x values were positive because I was moving right, and each of the y values was positive because I was moving up. In quadrant 2, they're both not going to be positive. So let's say I have this radius right here. It turns out that this is a 30, 60, 90 triangle. And in a 30, 60, 90, I know the shortest length is 1/2 and the longest leg is √3/2. But I've moved left and up. Left is a negative movement. Up is a positive movement. So my x values in quadrant 2 will be negative, and my y values in quadrant 2 will be positive. So the coordinate here would have been negative √3/2, 1/2. I'm going to do another one. Let's say in quadrant 3, I'm going to do this one right here, the 45-degree reference angle. This is a 45, 45, 90. I know both of the legs are √2/2. However, it doesn't mean the signs are positive or the same. For getting from this point to this point, I've moved left and down. Left is a negative movement, so that'd be a negative √2/2. Down is a negative movement, so that'd be a negative √2/2. So the coordinate would be negative √2/2, negative √2/2. So both the x and y value will be negative in the third quadrant. And think about it, that would make sense. This is the negative x-axis. This is the negative y-axis. Okay, last one that I'm going to do with you is, let's see, we've already done a 30-degree and a 45. Let's do the 60-degree reference angle. So if I were to connect this one, that would be 30 degrees. This would be 45. So here's my 60 right here. So I've created a 30, 60, 90. I know that the shortest leg is 1/2. The longest leg is √3/2. That's using my special right triangles of a unit circle. Now in quadrant 4, to get from the center to this point, I've moved right and down. Right is a positive movement. Down is a negative movement. So that would be a negative √3/2. All the x values would be positive. All the y values would be negative in quadrant 4. Again, think about it. It makes sense. This is the positive x-axis. This is the negative y-axis.